How do you find dependency information between tasks? Let me tell you something that you already know. Tasks can have parent tasks. They can also have child tasks. A task can have more than one child task, and a task can have more than one parent task. To better explain this question, I'm going to talk about the scenario. Let us say your manager comes to you and tells you that he wants you to document all the tasks in the project along with parent and child task information. How would you go about doing this? Here is where the task dependent view comes to our rescue. With the help of this function, what we can do is that we can find child information of all tasks. Finally, we need to talk about the word recursive, as you can see on your screen, and what recursive equal to true means. When we say recursive equal to true, the output has child tasks, grandchild task information, and it continues to show child task till it gets to the end of the tree of tasks. Let us see the task dependence in action by jumping into a demo where we will list child and grandchild tasks. In order to make it easier for us to understand the task and its dependencies, I have created this diagram which provides an outline of the task and the dependencies we are going to create. To begin with, at the very top, as you can see, we have a root task, and this root task has 4 children represented by C. They are one level below the root task and hence have been represented by LVL1. The name of the task is A, B, C, and D. That is followed by grandchild tasks level 2, and the task names are E and F. Finally, we have great grandchild task at level 3, G and H. An outlier here is the standalone task, in which I am trying to demonstrate that a given task can have multiple parents. So task H can have 2 parents here, or rather has 2 parents here. It has task E as well as task standalone as parents. We are going to start off by creating the database Cyrus. Since it already exists, we are going to go ahead and use it. Next step for us is to create the schema QA. Since it already exists, we are going to go ahead and use it. Let us see what tasks are available in the schema right now. Since this query produced no results, there are no tasks in this schema. The first step for us is to create the task called task_root. This is the root task, and I have set a schedule for this, and the schedule is set for 60 minutes. I've also given it a warehouse called compute_warehouse. The root task has now been successfully created. So task_root, which is the root task, has been successfully created. Next step for us is to create the child tasks A, B, C, and D, which are at level 1. Let's go ahead and do that. If you observe, I have used the after keyword here, and I have used the after keyword to indicate that task_root is the parent of task A. Similarly, I have used the same in task B, C, and D. What this does is that it creates a parent-child relationship between the task and the parent. Let's go ahead and run this. Four tasks have been created. We finished task_root and 4 child tasks have been created. Next step for us is to create task E and F, which are grandchild at level 2. Out here, we are going to create task E and task F, and their parents are A and A again here for F. Let's go ahead and create it. So 2 tasks have been created successfully, E and F with parent of A. The next step for us is to create the standalone task. The standalone task, as the name suggests, is standalone and is not dependent on any other task. And the final set of 2 tasks that we need to create are great grandchild G and H. G is dependent on E and H is dependent on E as well as standalone. Let's go ahead and create those. Out here, dependent on E, and for H, you can see that there are 2 tasks, E as well as standalone. So let's go ahead and create that. So the task has been successfully created. So let's just summarize what we have done so far. We created a root task called task underscore root. We created 4 child tasks, 2 grandchild tasks, 2 great grandchild tasks, and 1 standalone task. And when we created great grandchild task H, we made sure that its parent is task E as well as standalone. Our next step is to try and use task underscore dependence to find parent and child information. We are going to start off with the task underscore root task, and we will try and locate its parent and child. Now, before we run this query, let's try and make a guess as to what result this query should give us. I would think that if I run task root, it should give me these 4 child tasks. Let us run this and find out what it does. So as you can see on the screen, we have the task underscore root, which is the root task listed here, and its 4 children, as we had expected. The task root doesn't have any parents, because of which its predecessor, which is another word for parent, is blank. The next step for us is to run the same command for task A. Let's look at the diagram. A has a parent called task underscore root, and it has 2 children. So what do you think we should get as output for this query? What I would think is that it would tell us that task underscore root is the parent and E and F are the child of task A. Let's find out. As you can see, task A has a parent of task underscore root and E and F are its children. So it gave us predecessor, which is parent information, as well as child information. So we were able to locate the parent and children of task A. Now let us try and do that with grandchild task E. Grandchild task E is here. If we run this command for grandchild task E, what do you think we should get? I would think we would get task A as well as task G and task H, since those are the related tasks for E. Let's go ahead and run this query. E has a parent of A as expected, and E is the parent of G and H. An interesting thing you will note here is that H lists standalone also as the parent, and rightly so. As you can see, H has a parent of standalone in addition to E. That is the reason why when it came to parent, it displayed both the tasks. The next step for us is to run the command on task G. Task G doesn't have any children, but it does have a parent. So what do you think is going to be the outcome of this query? It should provide E as the parent, and since it does not have any children, it should basically come back with no children. Let's go ahead and run it. It has a parent of E, but since it does not have any children, it does not list any children. Let's run the same query for task H. Task H does not have any children. However, it has 2 parents, E and standalone. Let's see what the results are. In this particular case, since H has 2 parents, both E and standalone has shown up as parents. And since it doesn't have any children, therefore there is no child information here. So with the help of task dependence, we are able to see the immediate parent and the immediate child of a given task. However, we need to discuss what recursive means in the context of task dependent view. So far, we saw that whenever we provided a task name to the view, what it did was that it gave you the immediate parent and the immediate children of a given task. However, if you wanted a scenario where you gave a task name and you wanted your children name as well as your grandchildren name, how would you achieve that? And the answer to that question is recursive. If I gave task underscore root as the task name in the view, and set recursive to false, it would give me A, B, C, and D. However, if I set recursive equal to true, what it would do is, in addition to giving A, B, C, and D, it would also give me the grandchild and great grandchild information, because they are still related to the root task indirectly. So that is the primary difference between recursive and non-recursive. Now let's get into a demo and see how it works. I'm going to start off by running the task dependence query on the root task where I've set recursive equal to true. As I look through this, I can see that it has predecessor information as blank, obviously because task root does not have any parents. And then it has 4 children listed here, A, B, C, and D. However, you will also observe that it is now also providing grandchild information, E and F, and also showing what the immediate parent of that grandchild is. If you go down further, it is showing that great-grandchildren are present and provides information on who the parent of the great-grandchild are, which in this case is task E, and task standalone in the case of H. So what you're observing is that the way recursive works is that it provides child and grandchild information in addition to just the immediate child, which is what we saw when we use recursive equal to false. So depending on your need, if you want all the information about all the child tasks, then you can provide the root task name and get information about children and their children and so on and so forth till the end of the tree. With that, we conclude this question. If you have the time, please join me in the next question.